Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website, that is www.examsnet.com. This site is a great place for you to practice your entrance exam question papers, because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for the better preparation of your exams. So today, students, we will be solving JEE 2024 first Fab Shift 2 paper. In this particular video, I'll be solving the physics part of the paper. So here we go. Starting from the very first question of the physics part, that is question number 31. In an ammeter, 5% of the main current passes through the galvanometer. If resistance of the galvanometer is G, the resistance of the ammeter will be. So student, this question is from the chapter of magnetic effects of current and magnetism. Current and magnetism. In this question, it is given that 5% of the main current passes through the galvanometer. Okay, let us first draw the circuit diagram. This is the shunt resistance R. This is galvanometer G. And let us say I current is flowing through the circuit. Okay, so if I current is flowing in this circuit, so it will here divide into two parts. IG current will flow through the galvanometer and IS current will flow through the shunt resistance S. Okay, now since IS into S means the current into resistance of the shunt will be equals to IG into G. Okay, now 5% passes through the galvanometer. So if 5% passes through the galvanometer, so the remaining 95% will pass through the shunt resistance S. So 95% means 95 over 100. I current passes through this S into S. It will be equals to 5 over 100 I current into galvanometer G. So I cancels, 100 cancels. So S will be equals to G over 19. Let us say this is equation number 1. And we have to find the, if the resistance of the galvanometer is a G, okay, we have to find the resistance of the ammeter. Okay, so resistance of the ammeter will be, since this shunt resistance and the galvanometer, they are connected in parallel. So applying the parallel formula, so S into G over S plus G will be equals to, S is what? G over 19. So G over 19 into G over G over 19 plus G. Now solving it, we get resistance through the ammeter will be equals to G square over 19 over 20G over 19. This 19 cancels, 1G cancels 1G. So RA will be equals to G over 20. This is our final answer. So the correct option is option A, G over 20. Now next question, 32. To measure the temperature coefficient of resistivity alpha of a semiconductor, an electrical arrangement shown in the figure is prepared. Okay. The arm BC is made up of semiconductor. The experiment is being conducted at 25 degrees Celsius. And the resistance of the semiconductor arm is 3 milliohm. Arm BC is cooled at a constant rate of 2 degrees Celsius per second. So if the galvanometer G shows no deflection after 10 seconds, then alpha is okay. So this question is also from the chapter of magnetic effects of current and magnetism. Okay. See, continuous 2 question have been asked from the same chapter. Okay. According to the question, this BC arm is made up of semiconductor. Okay, and arm BC is cooled at a constant temperature of 2 degrees Celsius per second, and it shows no deflection after 10 seconds. After 10 seconds means delta T will be equals to, and since it is cooled means decreasing at a rate of this. So delta T will be equals to minus 10 into 2 Celsius per second means minus 20 degrees Celsius. Okay. Now let us say this is R1, this is R2, this is R3, and this is R4. So from the galvanometer property, from the galvanometer equation, we know that R1 into R4 is equals to what? R2 into R3. So R1 is of what? 0.8 milliohm and R4 is of 3 milliohm and R2 is 1 milliohm and R3 is, okay, we will find this R3. So from this solving it, we get R3 is equals to 0.8 into into 3 over 1 milliohm. So solving it, we get R3 is equals to A324 means 2.4 milliohm. So let us say this is equation number 1. Okay. Now since R3 is 2.3 milliohm, 2.4 milliohm, and rate of fall is what? Delta T, we calculated delta T as 20 minus 20 degrees Celsius. This is equation 2nd. So we have to find the value of alpha. So there is an equation for this. Delta R is equals to R alpha delta T. So alpha will be equals to delta R over R into delta T. See, according to question, at first, the resistance of the semiconductor is what? 3 milliohm. Okay. And it falls down to what? 2.4 milliohm. Na? So delta R will be 2.4 minus 3 milliohm. So it will be equals to 0.6 milliohm. So delta R here is minus 0.6 milliohm. Now putting the values, we get alpha equals to minus 0.6 milliohm over R. Originally the R is what? 3 and delta T is minus 20 degrees Celsius. So this minus minus cancels. Now solving it, we get alpha equals to 0.6 over 6 into 10 to the power 1 means 0.6 into 10 to the power minus 1 over 6. So we get alpha equals to 10 to the power minus 2 per degree Celsius. Okay, this is our final answer. So the value of alpha is 10 to the power minus 2. So the correct option is option C, that is minus 1 into 10 to the power minus 2 per degree Celsius. Okay, now next question is 33. From the statement given below, we have to find the correct options. Okay, so this question is from the chapter of modern physics. Modern physics. So the first statement is that the angular momentum of an electron in nth orbit is an integral multiple of h. So this is a correct statement. Since it is correct, since we know that angular momentum L equals to mvr and it is equals to nh integral multiple of this h. Okay, and we can write it as nh over 2 pi or it will be nh cat. According to Bohr's quantization, L equals to angular momentum is an integral multiple of h over 2 pi means L equals to n into h cat. So this option is correct. Okay. And second statement is nuclear forces do not obey inverse square law. Since this statement is also correct, since the inverse square law are followed by like electrostatic forces and like gravitational forces, but the nuclear forces are not does not obey inverse square law because nuclear forces acts between electron proton neutron proton proton neutron neutron proton neutron so they does not follow inverse square law. Like electrostatic force means F equals to k q square over r square and gravitational force means gm over r square. Okay, So this statement is also correct. Third statement is nuclear forces are spin dependent. Yes, it is very correct, since we are dealing with protons and neutrons and they have their own spins. So nuclear forces depends on spin. Okay. Fourth statement is nuclear forces are central and charge independent. This charge independent is correct, since proton neutrons, okay, and they this nuclear forces are central. This statement is wrong. Nuclear forces are not, are non-central forces. Central forces are like gravitational forces, okay. And E is stability of nucleus in inversely proportional to the packing fraction. Okay, this statement is also correct, since packing fraction is what? Packing fraction is mass of isotope minus mass number over mass number. So this ratio, mass of isotopes minus mass number to the mass number, this ratio is called the packing fraction. So the stability of nucleus is inversely proportional to the value of packing fraction. So this statement is also correct. So since A, B, A, B, C, and D, sorry, E and correct. A, B, C, and E and correct. So the correct option is option C. Now the next question 34. A diatomic gas gamma equals to 1.4 does 200 joule of work when it is expanded isobarically. The heat given to the gas in the process is okay. So this question is from the chapter of kinetic theory of gases. Kinetic theory of gases. So, using first law of thermodynamics. First law of thermodynamics. Since dq equals to what? du plus dw means delta q equals to delta u plus delta w. And we know that del w equals to p delta v. And del u is what? And cv delta t, na? So this q will be equals to p delta v plus n cv delta t. Okay. And cv is what? Cv equals to r over gamma minus 1, where gamma is this adiabatic constant. Okay. So we write q is equals to p delta v plus n r over gamma minus 1 into delta t. And for an ideal equation, we know that PV equals to nRT, to P delta V equals to, so this is T, nR delta T. So in place of nR delta T, we write P delta V. So Q is equals to P delta V plus P delta V over gamma minus 1. Okay. Now, Q will be equals to taking P delta V common. So we get 1 plus 1 over gamma minus 1. And the value of gamma is given as 1.4 for diatomic gas. So Q will be equals to P delta V. P delta V is what? Work done. And according to question, 200 joule of work is done. Okay. So in place of P delta V, we can write 200 into 1 plus 1 over gamma is what? 1.4. So 1.4 minus 1. So Q will be equals to 200 into 1 plus 1 over 0.4. So solving it, we get Q is equals to 200 into 3.5. So it will be equals to 700 joule. Okay, so the heat is what? 700 joule, means option D is correct. Okay. Now next question 35. A disk of radius r and mass m is rolling horizontally without slipping with speed v. If that moves up an inclined smooth surface as shown in the figure, the maximum height that the disk can go up to the incline is. So this question is from the chapter of laws of motion. Laws of motions. Okay. Since in this question, it is rolling horizontally without slipping, means there is no friction. So only translation kinetic energy of the disk changes into gravitational potential energy, and rotational kinetic energy remains unchanged since there is no friction. since there is no friction, so rotational kinetic energy will remain unchanged. Only the translational kinetic energy will change into gravitational potential energy. Okay, kinetic energy, it will change into gravitational potential energy. So translational kinetic energy half mv square will change into potential energy mgh. So from here mm cancels, h will be equals to v square over 2g. Very simple question. Okay, so the correct answer is option C. Height will be h equals to 1 by 2 v square over g. Now next question 36. Conductivity of a photodiode starts changing only if the wavelength of incident light is less than 660 nanometer. The band gap of photodiode is found to be x by 8. We have to find the value of x. Okay. This question is from the chapter of dual nature of matter and radiation. Matter and radiation. So we have to find the band gap. Band gap basically is the energy. Okay. We represent band gap as Eg. Okay, so this band gap Eg will be equals to, since energy is h nu, means hc over lambda, means h is what, Planck's constant, its value is 6.6 into 10 to the power minus 34 joule second. C is what, speed of light, the 3 into 10 to the power 8, and lambda wavelength is given as less than 660 nanometer. So we will write 660 into 10 to the power minus 9 meter. Now solving it, we get 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 over 660 into 10 to the power minus 9. Okay, at first it is in terms of joule, since Planck's constant is in terms of joule second. Na? So converting this joule into electron volt, so multiplying the denominator with 1.6 into 10 to the power minus 19. Now it is in the unit of electron volt. So solving it, we get band gap is equals to 15 over 8 electron volt. So comparing it with the equation given in the equation, x over 8 electron volt. So the value of x is 15. Okay, this is our final answer. So the correct option is option A, 15. Now next question 37. A big drop is formed by coalescing 1,000 small droplets of water. The surface energy will be. So this question is from the chapter of properties of solids and liquid. Properties of solids and liquids. Okay. Since 100 drops are making a big drop, means, sorry, 1,000 small droplets equals to one big drop. Okay, means the volume of 1,000 small droplets will be equals to the volume of the big drop. Means, let us say volume of okay, the radius of, let us say that this is a drop, and always the drop is in the form of a sphere. Okay, let us say the big drop have a radius of capital R and a small droplet has a radius of small r. Okay, so 4 by 3 pi r cube means the volume of the big drop will be equals to 1,000 into volume of the small droplets. Okay, so from this we get pi cancels, 4 by 3, 4 by 3 cancels. So capital R will be equals to 10 r. Okay, let us say this is equation number 1. Now we have to find the surface energy. Okay, so surface energy, initially surface energy is equals to 1,000 droplets into area into surface tension, as this makes surface energy. Surface energy means area into surface tension. Okay, and final energy will be equals to 4 pi capital R square into surface tension. Okay, so it will be equals to 4 pi and capital R equals to what? 10 R. It means 100 R square into S. Okay, so let us say this is equation second, this is equation third. So dividing equation second by equation third. by third. So we get ui over uf is equals to 1000 into 4 pi r square s over 4 pi into 100 r square s. R square s cancels, 4 pi cancels. This 2 0 cancel. So we get uf is equals to ui over 10. Okay. So the correct option is 1 over 10th time, option D. Now next question 38. If frequency of electromagnetic wave is 60 megahertz and it travels in a long z direction, then the corresponding electric and magnetic field vectors will be mutually perpendicular to each other, and the wavelength of the wave in terms of meter is. Okay, this is a very simple question, and it is from the chapter of electromagnetic waves. Okay, electromagnetic waves. Okay, just apply the formula of frequency. We know that mu equals to c over lambda. Okay, so we have to find what lambda means. Lambda equals to c over mu, where mu is the frequency. C is what? 3 into 10 to the power 8, and frequency is given as 60 megahertz, means 60 into 10 to the power 6 hertz. So just solve it. 320, so 1 by 2 into 10 to the power 8 minus 6 minus 1. So it will be equals to 1 by 2 into 10 to the power 1. It will be equals to 0.5 into 10. So it will be equals to 5 meters. So wavelength is lambda equals to 5 meter. Option C is the correct answer. Now next question 39. A cricket player catches a ball of mass 120 gram moving with 25 meter per second speed. If the catching process is completed in 0.1 second, then the magnitude of the force exerted by the ball on the hand of player will be, okay, in terms of SI unit. So this question is from the chapter of laws of motion. Speed is given as 25 meter per second. Mass is 120 gram. Okay. So we have to find the force. Okay. Force equals to, very basic formula, force equals to mass into acceleration. Now using first law of motion, V equals to U plus AT. So from this A is what? V minus U over T. So just apply this formula here. So F will be equals to M into V minus U over T. See, when the cricketer catches the ball, at that time the final velocity V becomes 0. Only we will consider the initial velocity. So the magnitude wise, force will be equals to mass is what? 120 gram. 120 gram means 0.12 kg, and into speed is 25, over time is what? 0.1 second. So force will be equals to 30 Newton. This is our answer. Option D is the correct answer. Now next question 40. Monochromatic light of frequency 6 into 14 hertz is produced by laser. The power emitted is 2 into 10 to the power minus 3 watt. How many photons per second on an average are emitted by the source? Okay, so this question is from the chapter of wave optics. Okay. Now, according to question, we have to find the number of photons. We have to find the value of n. And we are given with the frequency 6 into 10 to the power 14 hertz and power 2 into 10 to the power minus 3 watt. Okay. So there is very basic formula for this. Power equals to N into E. We all know this formula. Okay. And E, energy, is equals to what? H into nu, Planck's constant into frequency. So just apply the formula here. So N number of photons will be equals to power over H into frequency. Power is given as 2 into 10 to the power minus 3 watt, over Planck's constant is this 6.63 into 10 to the power minus 34, over frequency is given as what? 6 into 10 to the power 14 hertz. Just solve it and we get an equals to 5 into 10 to the power 15. Okay, so the correct answer is option C. Now moving towards next question 41. A microwave of wavelength 2 centimeter falls normally on a slit of width 4 centimeter. The angular speed of the central maxima of the diffraction pattern obtained on a screen 1.5 meter away from the slit will be. So this question is from the chapter of wave optics. So here in this question we are given with the diffraction pattern. Okay, and we are given the wavelength also. So let us say a light source is coming from this direction and this is a slit, and let us say this angle is theta, this angle is also theta. Okay, we have to find this whole angular spread. Okay, we have to find this whole angular spread, and we know the formula for central maxima is d sine theta equals to n lambda, and it is central maxima, so n is equals to 1. So d sine theta equals to lambda, where d is the slit width. Okay, so sine theta will be equals to lambda over d, and this lambda is of half of the angular spread, half of angular spread, since in this case when we are using this formula d sine theta equals to lambda, we are talking about only this angle, this theta, but we have to find the whole angular spread. So for whole angular spread, we have to multiply the theta with 2. Okay, so from here, sine theta will be lambda. Lambda is given as, lambda is what, 2 centimeter and width is 4 centimeter. So lambda is 2 and width is 4. So it will be equals to 1 over 2. So theta will be equals to sine inverse 1 by 2, and sine inverse 1 by 2 is what, 30 degree. Okay, so this theta angle is this half one. We have to find this whole to multiply this theta with 2. So the angular spread is equals to 60 degree. Okay, this is our final answer. So the correct option is option C. Now next question 42. C1 and C2 are two hollow concentric cubes enclosing charges 2q and 3q respectively as shown in the figure. The ratio of the electric flux passing through C1 and C2 is, okay. So this question is from the chapter of electrostatics. Okay. As we all know, electric flux phi is equals to 1 over epsilon naught times the total charge enclosed by the surface. Okay, so for the small cube, for a small cube, flux will be equals to, here for a small cube charge is 2q, so 2q over epsilon naught. For a small, let us say this is equation 1, and for big cube, plus is equals to 3q, and for big cube the total charge will be this 3q plus 2q, means total 5q charge. Okay, so 5q over epsilon naught, let us say this is equation 2. So total flux, okay, we have to find the ratio of the electric flux passing through C1 and C2. So ratio of electric flux will be phi small over phi big. It will be equals to 2q over epsilon naught over 5q over epsilon naught. Epsilon cancels, q cancels. So the ratio is 2 over 5, means 2 ratio 5. So the correct answer is option A. Now next question 43. If the root mean square velocity of hydrogen atom at a given temperature and pressure is 2 km per second, and root mean square velocity of oxygen at the same condition in kilometer per second is, okay, we have to find the RMS value for VRMS for the oxygen. Okay, now we know that, okay, this question is from the chapter of kinetic theory of gases. Since the formula for VRMS speed is what, under root 3 RT by M. Okay, where R is the gas constant, T is the temperature, and M is the molecular mass. So this 3 and R and T are constant. So it depends only on the mass M, molecular mass M. So for hydrogen, VRMS will be 1 over mass of molecular mass of hydrogen, and for oxygen, V of oxygen will be equals to 1 over molecular mass of oxygen. Okay, since hydrogen is a diatomic molecule also, so its molecular mass is 1, so 1 into 2 equals to 2, and for oxygen it will be 16 into 2. Okay, hydrogen means S2 and oxygen means O2, so 16 into 2 it will be 32. So VH equals to VH over V naught, it will be equals to under root of M of oxygen and M of hydrogen. Since velocity of hydrogen is given as 2 km per second, root mean velocity it is 2 km per second, we have to find the root mean square velocity for oxygen. So it will be equals to 32 over 2. So it will be equals to 2 over V naught under root of 216. So now 2 over V naught is equals to 4. So V naught is equals to 2 over 4 means 1 by 2. It means 0.5 kilometer per second. Okay. So the correct answer is option B. Now next question 44. A train A is moving along two parallel rails track towards north with speed 72 km per hour, and train B is moving towards south with a speed of 108 km per hour. Okay, velocity of train B with respect to A and velocity of ground with respect to B. Okay, we have to find the velocity of train B with respect to A and velocity of ground with respect to B. Okay, now this question is from the chapter of kinematics. Kinematics. Okay, now according to question, train A is moving towards north direction. Okay, let us say this is north direction and train A is moving in this direction. Okay, with a speed of 72 kilometer per hour. 72 kilometer per hour into 5 by 18 means now it is converted into what? Meter per second. So it is equals to uh 72 into 0.5 means 35. That is 6. Okay. No, sorry. Acha, 5 over 18. We have to multiply it by 5 over 18. So it will become 72. 2 9s are 18. 2 3s are 6. 1 7. 2 6 are 12. 3 1s are 3. 3 2s are 6. 3 3s are 9. 3 4s are 12. So it will be 20 meter per second. Okay. Now, and train B is moving in the southward direction. Train B is moving in southward direction means its velocity is given as 108 kilometer per hour. 108 kilometer per hour means 108 into 5 over 18 meter per second. So it will be equals to 30 meter per second. Okay. Now, considering north direction to be positive and south direction to be negative. Okay, we have to find the velocity of train B with respect to A. So velocity of B with respect to A, it means velocity of B minus velocity of A. Velocity of B is minus of 30 minus velocity of A is 20 means minus 50 meter per second, and velocity of ground with respect to B. Velocity of ground with respect to B. Velocity of ground minus velocity of B. Velocity is ground is considered as 0 minus velocity of B. So it will be 30 meter per second. So the correct answer is minus 50 and 30. Minus 50 and 30. So option C is the correct answer. Now next question. Next question is 45. A galvanometer G of 2 ohm resistance is connected in the given circuit, the ratio of charge stored in C1 and C2 is, okay. So this question is from the chapter of magnetic effect of current and magnetism. See, in this question, it is said that the capacitors are charged. It means the capacitors are fully charged. So when the capacitors are fully charged, we take the conditions of static current condition, okay. So what happen in static current condition? In static current conditions, the capacitor branches, we neglect the capacitor branches, okay. It means now the circuit diagram will look like this. 4 ohm, the current will go from here to here, then through galvanometer G, and through this it goes from here to here. So the current will flow like this, okay. Now this is 6-volt battery, okay. So in case of these C1 and C2, we consider these under static current condition, okay. Now for these, let us say the resistance, since here a total potential is 6-volt, okay. So now what we do at first, we will find out the current in the circuit, okay. First of all, we have to find the current that is flowing in the circuit. Since resistance will be, total resistance will be, this is 6 ohm and galvanometer resistance is 2 ohm. So total resistance will be 4 plus 2 plus 6. Since all are in series, so it will be 12 ohm, okay. So the current flowing through the circuit using Ohm's law, V equals to IR. So I will be V over R. So I will become, V is what? 6-volt. 6 over R is 12. It means 1 by 2 ampere current is flowing in the circuit. So here also the current is 1 by 2 ampere, and here also current is 1 by 2 ampere, okay. Now the potential is 6-volt, means here the potential is 6-volt and here the potential is 0-volt. Let us say we find the potential, we want to find the potential here. So let us say its potential is V, okay. So for this condition, we write V minus 0 is equals to I into R. I is what? 1 by 2. And in this branch, the R is 6 into 6. Okay. So V will be 3. So for this branch, means at this point, the voltage is 3. Okay. Now we want to find the potential at point this. Let us say this is point A, this is point B. So the potential at point B is 3 volt and we want to find the potential at A. So let us say this is V1. Okay. So for A point V1, this 6 volt. Okay. Sorry, this 6 minus this V1 equals to I into R. I is what? 1 by 2 into R. Resistance is 4 ohm. So 2 2s are 4. So 6 minus 2 equals to V1. So V1 is 4 volt, means at point A the potential is 4 volt and at point B the potential is 3 volt. Okay. Now we have find the potential at point A and the potential at point B. Okay. Now what we have to find? We have to find the ratio of the charge stored in C1 and C2. Now the charge at C2. For capacitance, we know that charge is equals to C into V. So C for C1, let us say this is for C1. For C1, the capacitance is given 4 microfarad and voltage is, here the voltage is 6 minus 3 means 3 volt, means 6 into delta V na, because here if we are considering this branch, so it comprises of 2 points, 6 volt and of 3 volt. So capacitance is 4 microfarad, means 4 into 10 to the power minus 6 into 6 minus 3. Okay. So it will be equals to 4 into 10 to the power minus 6 into 3. So it means 12 into 10 to the power minus 6. Okay. And for now C2 branch, for C2, Q will be equals to C into delta V again. and here C is what? In this branch, the capacitance is given as 6 microfarad, and here is 4 volt and 0. So 6 into 4, 6 into 10 to the power minus 6 into 4 minus 0. So it will be equals to 6 into 10 to the power minus 6 into 4 equals to 24 into 10 to the power minus 6 coulomb. Okay. Now, according to question, we have to find C1 and C2 ratio. Okay. So C1 over C2, it will be equals to C1 is what? C1 is 12 into 10 to the power minus 6 and C2 is 24 into 10 to the power minus 6. 10 to the power minus 6, 10 to the power cancels. It will be 1 by 2. So the correct answer is option D. Okay. Yes. Now the next question is 46. In a meter bridge, when a resistance in the left gap is 2 ohm and unknown resistance in the right gap, the balance length is found to be 40 centimeter. On shunting the unknown resistance with 2 ohm, the balance length changes by. Okay, so this question is from the chapter of current electricity. Current electricity. Now, according to the question, let us say this resistance is of 2 ohm and this is the, let us say, X resistance, okay? And this is a galvanometer G. This length is L and this will be 100 minus L, as we know that this length is of 100 centimeter, okay? Now, according to question, the left gap is of resistance 2 ohm and the balance length is of 40 centimeter. If this is 40 centimeter, then this will be 60 centimeter. So if the null point is at 40 centimeter, then using the formula for the meter bridge, that is, okay, 2 over 40 will be equals to x over 60. Okay, then we find that x is equals to 3 ohm. Okay, this is equation 1. Now the question is saying that on shunting the unknown resistance with 2 ohm. Okay, if we shunt this unknown resistance with 2 ohm, then we have to find the balance length. Okay, now if this is 2 ohm, so this 2 ohm and x, they are in parallel. So for this, R equivalent will become, let us say, this x dash. Okay, so x dash will become 2 into x over 2 plus x, and x is what? 3 ohm. So it will be equals to 2 plus 3 over 2 into 3 over 2 plus 3. So it will be equals to 6 over 5. Okay, means 1.2 ohm. Okay, now using again this condition for the new value of this x. So 2 over L will be equals to this x dash over 100 minus L, since we have to find this value of L. And value of this x dash is 1.2 ohm, as we have find right now. So 2 over L will be equals to 1.2 over 100 minus L. Now solving it, we get 200 minus 2L, it is equals to 1.2. So L. Okay, so 200 is equals to 1.2 L plus 2L. So from this, 200 will be equals to 3.2 L. So L will be equals to 200 over 3.2. So it will be equals to 62.5 centimeter. Okay, now the question asked about the balance length changes. So balance length changes will be equals to balance length changes by, at first it is 40 centimeter. So 62.5 minus 40 equals to 22.5 centimeter. So the balance length changes by 22.5 centimeter. That is option A is the correct answer. So the next question is 47. Choose the correct answer from the options given below. So this question is from the chapter of units and measurements. That is the first chapter. Okay. In this question, we have to find the significant figures. So in A, there is 1001 means the zero comes after 1. Okay, so the number of significant figure will be 1 2 3 4, that is 4 in A. So the A matches with second. Okay, now the second B is 010.1. Whenever the 0 comes before 1, so we will not consider as its significant figure. So this 0 has no significance, so the number of significant figure will be 3. So B matches with A, first option. Okay, and C1 is given as 100.100. In this, all the zeros comes after 1. So the number of significant figures will be 1, 2, 3, 4, 5, 6. That is, the C matches with 4. Okay. Now in D, these three zeros comes before 1. That is, they have no significance. So the number of significant figures in D are 1, 2, 3, 4, 5. That is, it matches with third. So A matches with second, B matches with first, C matches with fourth, and D matches with third. So the correct option is A matches with second, B matches with third, C fourth, and D third. So C is the correct answer. Okay. Now, question 48. A transformer has an efficiency of 80% and works at 10 volt and 4 kilowatt given as the power. Okay. If the secondary voltage is 240 volt, then the current in the secondary coil is. Okay. So this is a transformer. This is primary coil and this is secondary coil. Okay. In transformer, always there is a primary coil, and along with the primary coil there is a secondary coil. Okay, according to question, efficiency eta is given as 80% and uh power is given as 4 kilowatt. Okay, and it works at 10 volt means 10 volt means VP. Primary voltage is given as 10 volt, and if the secondary voltage is 240 means secondary voltage is given as 240 volt. We have to find the current in the secondary coil means we have to find IS. Okay, so using power formula, PI is equals to VP into IP. At first, we will find the value of IP. So IP will be equals to PI over VP. PI is what? 4 kilowatt. 4 kilowatt means 4 into 10 to the power 3 watt over VP is given 10 watt. So it will be equals to 400 ampere. Okay. Equation 1. Now we have to find the current through the secondary coil and using the efficiency. So eta is equals to IS into VS over IP into VP. So we have to find the value of IS. VS is given as 240 and IP is 400 ampere into VP is what? 10 volt. It is equals to given as 80. So solving it, we get IS is equals to 80 into 400 into 10 over 240. Okay, this 0 cancels this. Solving it, we get IS is equals to 13.33 ampere. Okay, this is our final answer. So the correct option is option B. Now next question 49. A light planet is revolving around a massive star in a circular orbit of radius r with a period of revolution t. If the force of attraction between planet and the star is proportional to r to the power minus 3 by 2, then choose the correct option. Okay, so this question is from the chapter of gravitation. In this question, we are given that the force of attraction between the planet and the star is proportional to r to the power minus 3 by 2. A planet is, let us say this is a star, and a planet is revolving around the star in the circular orbit. This is planet. Okay, and its radius is r, okay? And t is the time of revolution. And the force acting between this star and planet is directly proportional to r to the power minus 3 by 2. Now, when we remove this proportionality sign, then a proportional constant comes k, let us say it is k into r to the power minus 3 by 2. So f will be equals to k over r to the power 3 by 2. This is equation 1, okay? And also when this planet revolves around the sun, so it will also experience a gravitational force. So this gravitational pull, we can say, this gravitational pull introduces centripetal force, okay? Introduces centripetal force here, and centripetal force will be equals to F will be equals to m omega square r. So from equation first and second, k over r to the power 3 by 2 will be equals to m omega square r. So omega square will be directly proportional to 1 over r to the power 3 by 2. And we know that time is what? 2 pi over omega. In question, we have to find what? Time, na? So time is directly proportional equals to 2 pi over omega. So from this, omega will be equals to 2 pi over t. Omega square means 2 pi over t square. Okay, so it will be proportional to 1 over r to the power 3 by 2. Okay, so okay, here is 1 r also. Okay, so omega square will be proportional to r 3 by 2 plus 1 plus 1. Okay, so t square will be directly proportional to r to the power 5 by 2. This is our final answer. So option A is the correct answer. Okay, now next question 50. A body of mass 4 kg experiences two forces F1 and F2. The acceleration acting on the body is. So this question is from the chapter of kinematics. Okay, we are given two forces F1 and F2 and we have to find the acceleration acting on the body. So F1 is given as 5 iota cap plus 8 j cap plus 7 k cap, and F2 is given as 3 iota cap minus 4 j cap minus 3 k cap. So first of all, we will find the net force. So net force will be equals to F1 plus F2. So it will be equals to 8 iota cap plus 4 j cap plus 4 k cap. Okay. And we know that F is equals to mass into acceleration. So acceleration will be equals to F over m, and we are given m as 4 kg. So 1 over 4 into force. Force is what? 8 iota cap plus 4 j cap plus 4 k cap. So acceleration will be 2 iota cap plus 2 j cap, sorry 2 iota cap plus 1 j cap plus 1 k cap. So the answer is 2 iota cap plus j cap plus k cap, means option C is the correct answer. Okay, so the next question is 51. A mass m is suspended from a spring of negligible mass and the system oscillates with a frequency f1. The frequency of oscillations if a mass 9m is suspended from the same spring is f2. Okay, we have to find the value of f1 over f2. So this question is from the chapter of oscillations and waves. Oscillations and waves, okay. Now we know that the frequency omega is equals to under root k over m. Okay, we know that the angular frequency, or we can say angular speed, whatever, it is equals to under root k over m. Okay, so for the uh, mass m, only m, it is omega will be equals to under root k over m. let us say it is omega 1. And for mass 9m, omega 2 will be equals to under root k over 9m. Okay. Let us say this is equation 1, this is equation 2. Okay. We know that omega is equals to 2 pi f, where f is a frequency. So f will be equals to omega over 2 pi. Okay. So f1 will be equals to omega 1 over 2 pi. So omega 1 is what? 1 over 2 pi under root k over m. Let us say this is equation 3, and f2 will be equals to omega 2 over 2 pi. So it will be equals to 1 over 2 pi, and omega 2 is what? K over 9m. This is equation 4. We have to find the value of f1 over f2. So f1 divided by f2 will be equals to 1 over 2 pi under root k by m over 1 over 2 pi under root k over 9m. 1 over 2 pi, 1 over 2 pi cancels, under root k cancels, under root m cancels. So we get f1 over f2 is equals to under root 9 over 1. It will be equals to 3 over 1. So f1 over f2 ratio is equals to 3 over 1, 3 by 1. Okay, this is our final answer. Now next question, 52. A particle initially at rest starts moving from reference point x equals to 0 along x-axis with velocity v and varies as v equals to 4 root x meter per second. So we have to find the acceleration of the particle. Okay. So this question is from the chapter of kinematics. In this question, we are given with velocity v. So velocity v is 4 root x meter per second, and we have to find the acceleration, and we know that acceleration is equals to del v over del t. Also it is equals to v del v over del x. Okay, now using this formula, a equals to v del v over del x. V is what? 4 root x, and del by del x of v is what? 4 root x. Now solving it, we get a is equals to 4 root x, and del by del x of 4 root x means 4, and del by del x of x to the power 1 by 2. So solving it, we get 16 root x 1 by 2 x 1 by 2 minus 1. So it will be equals to 16 root x into 1 by 2 into x to the power minus 1 by 2. Okay. So it will become 2 8s are 16. So acceleration will be equals to 8 root x over root x. This root x cancel. So we get acceleration equals to 8 meter per second square. So the acceleration of the particle is 8 meter per second square. Okay. Now next question, 53. A moving coil galvanometer has 100 turns and each turn has an area of 2 centimeter square. Okay, the magnetic field produced by the magnetics 0.01 Tesla and the deflection in the coil is 0.05 radian, where when a current of 10 milliampere is passed through, the torsional constant of the suspension wire is x into 10 to the power minus 5 Newton meter per radian. We have to find the value of x. Okay, so this question is from the chapter of magnetic effects of current and magnetism. Current and magnetism. Okay, we are given a number of turns of the galvanometer n equals to 100, area equals to 2 centimeter square, magnetic field B as 0.01 Tesla, and deflection theta equals to 0.05 radian, and current I is 10 milliampere. We are asked to find the torsional constant. Okay, so we know that there is a relation between torque and magnetic field, and it is given as torque is equals to BINA, where tau is what? Torque, and in terms of torsional constant we write it as C into theta equals to BI NA, where C is the torsional constant. Okay. Now this C will be equals to BI NA over theta, and we are given B is 0.1 Tesla. Current is 10 milliampere, means 10 into 10 to the power minus 3 ampere into n number of turns is 100 into area is 2 centimeter square, means 2 into 10 to the power minus 4 meter square over theta. Theta is 0.05 radian. So solving it, we get 0.01 into 10 to the power minus 3 minus 4 minus 7, 2, 1, 3 plus 3, and into 2 divided by 5 into 10 to the power 2. Okay, so it will become 4 into 10 to the power minus 5 Newton meter over radian. Now comparing it with the equation given in the question, x into 10 to the power minus 5. So comparing it with x into 10 to the power minus 5, we get x is equals to 4. So this is our final answer. Now next question 54. One end of a metal wire is fixed to a ceiling and a load of 2 kg hangs from the other end. A similar wire is attached to the bottom of the load and another load of 1 kg hangs from this lower wire. Then the ratio of longitudinal strain of the upper wire to that of lower wire will be. So this question is from the chapter of properties of solids and liquids. Now, according to question, let us say one end of a metal wire is fixed to a ceiling and a load of 2 kg. Okay, this is of 2 kg hangs from the other end. A similar wire is attached to the bottom of the load and another load of 1 kg. Okay. Now the question is asking to find the longitudinal strain of the upper wire to that of the lower wire. Okay. We know that Y, Young's modulus, is equals to force over area into L over elongation in length delta L. Okay, we have to find the longitudinal strain. So we know that delta L over L is the longitudinal strain. So we have to find this value for the upper wire as well as for the lower wire. Okay. So from this we get delta L over L equals to what? F over A into Young's modulus Y. So using this formula, delta L1 over L1 over delta L2 over L2. This is for upper wire and this is for lower wire. It will be equals to, since area is constant, Young's modulus is constant, so we will use only F1. So it will be directly proportional to F. So it will be F1 over F2. So F1 is given as what? F1 is, okay, F1 will be 30 and F2 will be 10. Why? Since here T1 is acting na, so T1 will be equals to 2 plus 1, 3. Total mass will be in the downward direction 2 plus 1, 3 kg na. So here T1 will be 30 Newton and here T2 will be of 1 kg, means 10 Newton. So F1 is what? 30 Newton and F2 is 10 Newton. So F1 is 30, F2 is 10. So solving it, we get the ratio of the longitudinal strain of the upper wire to that of lower wire is 3. So our final answer is 3. Okay. Now next question 55. A particular hydrogen-like ion emits the radiation of frequency 3 into 10 to the power 15 Hertz when it makes transition from n equals to 2 to n equals to 1. The frequency of radiation emitted in transition from n equals to 3 to n equals to 1 is, okay, we have to find the value of x. So this question is from the chapter of atomic and nuclear physics. Now, we know that the energy formula is what? Minus 13.6 z square over n square, okay? If we are having transitions from, let us say, n equals to ith state to n equals to final state, initial state to final state, then we can write this energy expression as minus 13.6 z square into 1 over ni square minus initial, this is initial minus 1 over final square, okay? So E will be equals to this, we can write as constant C because this will be same for all. So constant C into 1 over nf square minus 1 over ni square. Since here it is minus sign, to multiplying this minus sign in the bracket, so we get 1 over nf square minus 1 over ni square. And we know that E is equals to h nu, Planck's constant, into frequency. So we can write h nu equals to this constant into 1 over nf square minus 1 over ni square, okay? Now this h is also constant. Since it's Planck's constant, this is also constant, so we can write nu1 equals to 1 over nf square minus 1 over ni square when the transition is from 2 to 1, and nu2 is equals to 1 over nf square minus 1 over ni square when the transition is from 3 to 1 according to question. At first, the transition is from 2 to 1, and we are given 3 into 10 to the power 15 hertz frequency. Now we have to find the frequency when the transition is from 3 to 1. So we are using the transitions from 2 to 1 and from 3 to 1. So for 2 to 1, we can write it as nu1 is equals to 1 over 1 minus 1 over 4. 2 square is 4 over nu2 is equals to 1 over 1 square means 1 over 1 over 3 square means 9. So it will be equals to 3 by 4 and it will be equals to 8 over 9. So nu1 over nu2 will be equals to 3 by 4 into 9 over 8. Okay. So it will be equals to 9 3 27, 8 4 32. And we are given nu1 as what? Nu1 as 3 into 10 to the power 15. Okay. So we get nu2 equals to 32 over 27 into nu1, and it is 32 over 27 into 3 into 10 to the power 15. So 3 9s are 27. So solving it, we get nu is equals to 32 over 9 into 10 to the power 15 hertz. So this is our final answer. So according to question, we are given x over 9. So here the value of x is 32. Okay. Now, next question 56. In an electrical circuit drawn below, the amount of charge stored in the capacitor is microcoulomb. We have to find the amount of charge stored. Okay. So to find the amount of charge stored, we know that at first the capacitor is fully charged. Okay. When the capacitor is fully charged, we say that it now comes under static condition. And under static condition, the wire acts as a open circuit wire. Okay. The circuit acts as open circuit. Okay. To find the charge stored in the capacitor, first we have to charge it fully. So when the capacitor gets fully charged, it comes under the static condition, and under static condition, it acts as a open circuit. So this capacitor will act as a open circuit. Now this circuit becomes as, this is 10 volt, this is R1. Now let's see, this acts as an open circuit, this is R2, and this will be R3. Okay, this is of 4 ohm, this is of 5 ohm, this is of 6 ohm. and this is of 10 volt. Okay, so now let us say this is point A, this is point B. So whatever be the value of point A and point B, it will be the value of A dash and B dash. Okay, whatever be the value of point A and point B, means voltage at point A and point B, it will be the voltage at point A and point, sorry, A dash and B dash, and this will act as A and B. Okay, now since we know that from Ohm's law, V equals to I into R. So for this circuit, if you want to find the value of I, it is equals to V over R. V is what? 10 volt, and R is what? If the current is flowing in this direction, let us say, so it will be equals to this 4 ohm and this 6 ohm. 10 ohm, since these are in series, so current will be 1 ampere. Okay, in this circuit the current will be 1 ampere. Okay, now for this A and B, for A and B, again using V equals to IR, so VA minus VB is equals to I into R. I is what? 1 ampere, and R is 6 ohm, so it will be equals to 6 volt. Okay, now whatever be the voltage difference between this A and B will be the voltage difference between A dash and B dash. Okay, since it is acting as an open circuit. Now we want to find the value of charge. We know that for a capacitor, charge Q is equals to capacitance into voltage. Capacitance is given as 10 microfarad, means 10 into 10 to the power minus 6 farad, into potential difference is what? 6 volt. So it will be 60 microfarads. Sorry, we have to find the charge na, microcoulomb. Okay, charge will be 60 microcoulomb. Okay, Q into delta V na, and delta V is 6 volt. Yes, it will be 60 microcoulomb. Okay, now next question 57. A coil of 200 tons and area 0.20 meter square is rotated at half a revolution per second and is placed in uniform magnetic field of 0.01 Tesla perpendicular to the axis of rotation of the coil. We have to find the maximum voltage generated in the coil. Okay, we have to find this value of beta. So this question is from the chapter of electromagnetic induction and alternating current. Magnetic induction and alternating currents. Okay, now we know that the flux, magnetic flux phi is equals to NAB cos omega t. Okay, and whatever be the EMF generate in the wire, E will be equals to minus del phi over del t. It will be equals to, taking magnitude wise, it will be equals to d by dt of NAB cos omega t with a minus sign. Okay, so differentiating it, we get epsilon EMF will be equals to, EMF will be equals to NAB omega sin omega t. And if we want to find the maximum value, so for EMF maximum, the sin omega t will be maximum, and the value of maximum sin theta is 1. So we get NAB into omega. So maximum voltage means maximum EMF will be NAB into omega. N is given 200. Area is 0.20 meter square. And B is 0.01 Tesla. Okay. So we will write N is 200. Area is 0.20. B is 0.01 and omega is pi. Okay, so we get 4 pi over 10. It will be equals to 2 pi over 5 volt. Okay, so the value of beta will be equals to 5 by comparing it with the given question. So this is our final answer. Now next question 58. In Young's double slit experiment, monochromatic light of wavelength 5000 angstrom is used. The slits are 1.0 meter apart and a screen is placed at 1 meter away from slits. The distance between the center of the screen where intensity becomes half the maximum intensity. Okay. So this question is from the chapter of wave optics. Let us first understand this question by a figure. Okay. Let us say this is slit S1. Okay. And this is slit S2. Okay. This is the screen. The monochromatic light is coming like this and it is like this. Okay. Let us say this distance, the distance between slits and the screen is capital D and the distance between the two slits is D. Okay. Let us say the intensity of the monochromatic light is I0, and this distance is Y. Okay. Now, according to question, we are given that the wavelength lambda of the monochromatic light is 5000 angstrom and the slits are 1 millimeter apart, means small d is 1 millimeter and the screen is placed at 1 meter from the slit, means capital D is 1 meter. Okay. The distance from the center of the screen where the intensity becomes half. Okay. We have to find the point where the intensity distance where the intensity becomes half. We know that the maximum intensity formula is given as I is equals to I maximum cos square phi by 2 delta phi by 2 and delta phi is the phase difference. Okay. For a monochromatic light this remains constant. So according to question, we have to find the distance at which the intensity becomes half of the maximum intensity. Means here in place of this intensity, we write I maximum by 2. It is equals to I maximum into cos square delta phi by 2. So this I maximum cancels. We get cos square delta phi by 2 equals to 1 by 2. So cos del phi by 2 will be equals to 1 by root 2. Okay. Now from this we can write del phi by 2 as cos inverse 1 by root 2. And for this we can write delta phi by 2 equals to pi by 4. Okay. So pi by 4. So we can write delta phi equals to pi by 2 from this. Okay. Now let us say this is equation 1. Now there is a relation between part difference and phase difference, that is 2 pi over lambda into delta x equals to what? Delta phi. So from this we can write 2 pi over lambda into delta x equals to delta phi is what? Pi by 2. So from here delta x becomes, this pi cancels. It becomes lambda by 4. Let us say this is equation 2. Okay. Now let us say delta x is what? Delta x is the part difference. Part difference, what? This from slit S1 to S2. Let us say this is the point where the intensity is I max by 2. And for this, we have to find this distance. So for a monochromatic light coming from slit S1 to point, let us say this is point D, capital P. And to coming light coming from point slit S2 to reach the point P. So this part difference is, let us say, delta X. Okay. So this delta X will be this D over, let us say this is angle theta. This is angle theta. Okay. So this delta X will be equals to D tan theta. Now using this equation, D tan theta will be equals to delta X. So delta X will be equals to D into tan theta. Tan theta is what? Y over this capital T. Okay. Tan theta will be Y over this capital D. So delta X is what? Lambda by 4. Lambda by 4 will be equals to dy over capital D, and we have to find this distance y. So this y will be equals to lambda d over 4d. Now putting the values, lambda is 5000 angstrom, means 5000 into 10 to the power minus 10, and this capital D is 1 meter, small d is 1 millimeter. Capital D is 1 meter, small d is 1 millimeter, means 1 into 10 to the power minus 3. So solving it, we get 2 2s are 4, 225 into 0 0, 2 1s are 2, 2 2s are 4, 1 5, 2 5s are 10 0. So it will be equals to 125 into 10 to the power minus 9 plus 3. So it will be equals to 125 into 10 to the power minus 6 meter. Okay, this is our final answer. So the next question is 59. A uniform rod AB of mass 2 kg and length 30 centimeter at rest on a smooth horizontal surface. An impulse of force 0.2 newtons second is applied to and B. The time taken by the rod to turn through at right angles will be pi over x. We have to find this value of x. Okay. So let us try to understand this question. So we are given a uniform rod AB. Okay, let us say this is A, this is B, and the mass of the rod is given as 2 kg, and its length L is given as 30 centimeter. Okay, now initially it is at rest. According to question, it is at rest on a smooth horizontal surface. An impulse force of 0.2 Newton second is applied to end B. Let us say we are applying an impulse force of 0.2 Newton second at the point B. Okay, when we apply this impulse at the point B, so this rod will do rotation motion, it will turn. So since the point B is not fixed, it is free at point B, so it will rotate along the center of mass. Okay, it will rotate around the center of mass with an angular speed of omega. Since it is not fixed at point B, it is free at point B, so it will rotate or revolve around the center of mass with a speed omega. Okay, now angular impulse about center of mass cm. So angular impulse will be equals to I, it will be equals to R cross J, where J is the linear impulse and I is the angular impulse. So it will be equals to L final minus L initial. Okay. Now, since the rod is of length L, so from the center of mass, it is of L by 2, and the impulse is acting in this direction. So this angle will be 90 degree. This angle will be 90 degrees. So we can write L by 2 into this 0.2 into sine 90. Impulse is 0.2 na, so L by 2 into 0.2. Since the angle between impulse and the length of the rod from the center of mass L by 2, the angle between them is 90 degree. So we can write L by 2 cross J. J means 0.2 into sine 90. It will be equals to L final. L final is what? I center of mass into omega minus, initially this is at rest, so it will be 0. So we can write L by 2 into 0.2 into sine 90 is 1 equals to, for a rod, this I is equals to what? 1 by 12 ml square. So we can write 1 by 12 ml square into omega. So from this, omega will be equals to 0.2. This L cancels, 2 6 are 12. So omega will be equal to 0.2 into 6 over ml. Okay. So omega will be equal to 0.2 into 6. M is what? M is 2 kg and L is 30 centimeter. So it will be equals to 2 into 0.3. 2 3 are 6. 3 into 0.1, so it will be equals to 2 by 1 means 2. So from this, we get the value of omega, that is 2. This is equation 1. Okay. Now, since the impulse is acting at B, so when the impulse is acting in this direction, so after some time, the rod will become like this. This will be point A, this will be point B. So initially the rod is like this, AB. Now the rod is like this. So the angle between them is what? 90 degree. So now we can write theta as what? Pi by 2. Okay. So, and we know that theta equals to omega into T. So from this, we get T is equals to theta over omega. So omega is equals to, so for this we can write theta is what? Pi by 2. So pi by 2, and we get from equation 1 omega equals to 2. So we get T equals to pi by 4. And in the question we are given T equals to pi by x. So comparing it with this, T equals to pi by x equals to pi by 4. So we get the value of x as 4. This is our final answer. Now next question 60. Suppose a uniformly charged wall provides a uniform electric field of 2 into 10 to the power 4 Newton per coulomb normally. A charged particle of mass 2 gram being suspended through a silk thread of length 20 centimeter and remains stayed at a distance of 10 centimeter from the wall. Then the charge on the particle will be, we have to find this value of x. So this question is from the chapter of electrostatics. Now, in question, we are given that we have a uniform electric field. Okay, let us say the electric field is in this direction, uniform one, okay? And a charged particle of mass 2 kg being suspended through a silk thread of length 20 centimeter. Let us say this length is of 20 centimeter, okay? The main stayed at a distance of 10 centimeters. So this distance D is given as 10 centimeter. Let us say this angle is theta. Okay, now when we resolve this length L, this force Q is E is acting in this direction due to this uniform electric field. Okay, and downward force mg is acting in this direction. T cos theta, let us say this angle is theta due to this angle, so T cos theta will act in this direction and T sin theta will act in this direction, okay? Now, from here, T sin, only sin theta, for this angle theta, sin theta will be equals to what? 10 over this 20, since sin theta is perpendicular over hypotenuse. So this angle is theta, this angle is of perpendicular. So perpendicular over this 20 hypotenuse. So sin theta will be 10 over 20. It will be equals to 1 by 2. So for this triangle, for this theta will be equals to 30 degree. Okay. Let us say this is equation 1. Okay. Now from using these, we get T sin theta for equilibrium condition will be equals to QE and T cos theta will be equals to mg. Now dividing it, T cancels. If T is a tension acting in this, so tan theta will be equals to QE over mg, and theta is what? 30 degree. So tan 30 will be equals to Q into E. E is given as 2 into 10 to the power 4, 2 into 10 to the power 4 over mass. Mass is 2 kg, 2 gram. Mass is 2 gram. 2 into gram 10 to the power minus 3 into gravity is 10. Okay. And this tan 30 will be equals to 1 by root 3 equals to Q into 2 cancels 10 to the power 4 plus 3 minus 1. So 1 by root 3 will be equals to Q into 10 to the power 4, 5, 6, 7 minus 1, 6. So Q charge will be equals to 1 by root 3 into 10 to the power minus 6 coulomb. Now comparing it with the given equation in the question 1 by root 6 microcoulomb. So comparing it with 1 by under root x into 10 to the power minus 6 coulomb. So we get x is equals to 3. So this is our final answer.